Okay, so this video will be about accessing MaxQuant and running MaxQuant back on the Wednesday grid. So as we can see here, first things first, we want to be on the Wednesday VPN. So I'm going to do that. It will send me a duo push on my phone. And if you're not at your house, you can just do this by being on the Wi-Fi or being on the internet at Wednesday directly. Okay, so now we're connected. I'm going to want to go to this website here. Let me find it. So ondemand, create.win.edu, and then type in your password. And you should be able to connect. So now we're connected. This is where all the grid services are, right through your browser. So as before, as I mentioned, up here you're going to see your directory. Each student that has a grid account is going to have a directory. You can also run jobs, submit jobs. Here, you can actually access the grid, the shell here, and you can also run interactive apps. So we're going to run MaxQuant here. So now that we're in here, I'm going to go to the main directory folder, your home directory. For me, it's GA2599 because that's my access ID. And I'm going to go into another folder called demo, just to show you how MaxQuant can be ran. So for this demo, all that we really need is the raw files. These are the output from a mass spectrometer, specifically a Thermo Fisher one. And here we have 3 different conditions as well as a wild type. And then we also need a search space. So we have a FASTA file here that's a human Swiss prot FASTA file. So now that we have, we know where our data is, we can actually run this. So we're going to go back to the main page and go to interactive apps, click on MaxQuant. And here we can run MaxQuant GUI on, like the GUI, the graphical interface, basically like how you can run it on your local computer, but in XFCE desktop environment on the Wednesday grid. So you can choose the queue that you want to be in. It's primary queue, secondary queue. Primary queue is, as it says here, faster, but it's a bit more busy. And the number of hours that you want. Right now they have a 48-hour limit. And then you can choose the number of CPU cores, as well as amount of RAM. For MaxQuant, you need about 2 gigs of RAM for every core that you use. And furthermore, sometimes if you don't request the right number of cores, then you can run into some issues with you'll always be in queue looking for a node to run on, but it won't work. So make sure you reference the grids available nodes before you choose the number of cores that you want. We can click launch. And as you can see here, it's starting. This is another run that I have going on right now from earlier today. Okay, so now it started already. So it's running on host WSU 8, and we just created now. We can hit this button to launch MaxQuant. So it's going to open up another tab, and in this tab, we're going to see MaxQuant. So it's just like a window in your desktop. It's like remote desktop, basically. So we're running right now MaxQuant version 1.6.10. And the first things that you want to do, so down here, just to let you know, there's different tabs for the different steps in running MaxQuant. And when you're ready to run it, you just hit the start button. The first thing we're going to do is pump this up to 8 cores, because we're running on a core node. Then we can load in the data. So it's going to open up our home directory, and I can go to the demo folder, pick all of these. So they'll be loaded in here. What you want to do now is assign parameters, experiments, and fractions. Don't worry about the PTM. So the experiment is the experimental condition. So because these are all different experimental conditions, sometimes you might have replicates, and in that case you might have three different rows here for one condition. Then you would have to assign them to the same experiment. So I'm going to click set experiment. This is the H, so I'll just get H. This one is S, so we'll get S. Set experiment, get a T, and get a Y type. Okay, now the experiments are set. If we wanted to have different parameters, which for example, a parameter would be the type of enzyme used, we'd want to assign a different parameter group to specific raw files. But in this case, everything's going to be the same parameters, so we'll keep it as group 0. Now, if you do have fractions, that's fractions in the sense of liquid chromatography or tandem mass spec, and you want to group them all together, you can set the fraction number as well. But we're not going to worry about that now. So moving on to group specific parameters, we're in group 0, there's only one group. So we can go right to the modifications tab, and this is where you'll add any modification that you're looking for. These are all the basic ones. If you look down here, it should be hexnac. So if we're doing nucleic calculation, we're looking at for hexnac. Hit this little arrow to bring it over. These are fixed modifications down here, which we don't really need to worry about. This all really depends on how you process your protein before you put it in the mass spec. With carbamidomethylation being like something that's very common. So that's why it's there. The instrument, here you'll set the instrument type, the OB trap. You can change the tolerances as well. Most of it as default is, if you're not sure, you can keep it like that. Don't really need to worry about first search modifications. Digestion, let's change the type of enzyme that you use just by moving it over. We're going to keep trips in here. You can also do label-free quantification. And then the type here. Yep, so this is if you're doing labeling. But we're just going to do basic labeling here. So at this, if we move on to global parameters, we're going to add the FASTA file that we're going to search. Now it's ready. And you can remove contaminants if you want to go faster, but let's keep contaminants. That's a good thing to look for. There's different options here. So remove some tables. So some more tolerances that you can change. Advanced stuff. Some more FDRs that you can change, but most people keep 1%. Here's for LFQ. You can also do check IVAC. I think we're going to keep that in our case. Although that depends on your experiment, of course. And the rest is not really important. Performance, we can hit the run button, start, just start running MaxQuant. Hit show all activities, it will show with each step that you're on. And then yeah, so at this point, you'll just wait and you can exit out of your tab, out of your browser, and you can come back later and check on it. It will still be running on once it's signed. The last thing I want to mention is the configuration. So this is where you can add more. So these are different types of PTMs, different types of modifications. You can edit them. These are the ones that have come with MaxQuant, you know, already, but you can add new ones if you want as well. Through this add button. Basically here, you would just add the name, what is being added, where it can be added, so anywhere in this case. But some of them are only on example. So I think, for example, here is only on the end terminus. It really depends on what you want. So if you have a custom tag, you can add your own tag. But yeah, as you can see here, we're getting some results. So it's just starting with feature detection as usual. And then I guess one thing to look for is what it's going to look like when it's done. So just make sure you don't hit this button. It will exit MaxQuant, but you can exit out the browser or the tab. If I go back to our home directory, what the data will look like when it's done is something like this. So you're going to see these were the raw files that you had. Now there's going to be an index file for each raw file, corresponding one, as well as an MQPAR file. If you click Save here, File, Save Parameters, it will save as automatically. It will save as MaxQuant par parameters, but you can give it a different name. And this is if you want to reuse your parameters. Let's say you got an error, or you want to have multiple runs just to test. You can use the same parameter file. We also see these folders, which are really important, as well as this combined folder. So if we go in here, the important folders to pay attention to is proc for processes. This will show, a table for each step, as well as this running times table. If you click View, you can see the different steps. The first step is configuring, start time, end time. And then the last step, if there's no error, should be writing finish tables, finishing writing tables. That's just something to note. And then all the results will basically be in this txt folder. So in this case, this summary, this table's PDF will help you understand what each table means and what you can do with each table. The tables that are most important would be protein groups and evidence. And another one that's important if you're looking at a specific PTM, which I assume you are, would be one of the PTMs that you added. In our case, we added HexNac. We're looking for glycan inflation, so this will be also important. So at this point, I think we're pretty much done for this video. I will go into some other filtering and data cleanup steps in the next video. So thanks for watching.